September 26, 1918, 5:30 a.m. Coordination Headquarters, Sully-Meuse Sector, France. Colonel Johnson Hagood, Chief of Staff for the American Services of Supply, stood before a wall-sized map dotted with colored pins representing supply depots, rail junctions, and ammunition dumps, stretching across 200 miles of American-controlled territory. In 6 hours, 1.2 million American soldiers would launch the largest offensive in United States military history, the Meuse-Argonne attack. Hagood's hand trembled slightly as he traced the supply routes feeding this massive force. 3,980 artillery pieces requiring 40,000 shells daily, 500,000 rifles demanding constant ammunition resupply, 324 tanks needing fuel and spare parts, field hospitals requiring medical supplies for anticipated casualties exceeding 100,000. His logistics network would need to deliver 750,000 tons of supplies per month to maintain offensive operations. Hagood had commanded supply operations in the Philippines, understood military logistics according to conventional doctrine, and had studied European supply systems since arriving in France. But nothing in his training had prepared him for supplying an offensive of this scale through a devastated region whose infrastructure the Germans had systematically destroyed during their March retreat. What Hagood didn't know, what no American logistics officer would fully understand until the offensive's conclusion 47 days later, was that the services of supply organization he commanded represented an entirely new conception of military logistics, one that applied American industrial methods and railroad management techniques to warfare on a scale that made traditional European supply doctrine obsolete. While German commanders dismissed American organizational capability as chaotic amateurism, the American expeditionary forces had constructed the most extensive military supply infrastructure in history. 3,000 miles of railway track built in 12 months, 10 major ports handling 7.5 million tons of supplies, storage facilities covering 7 million square feet, and a telephone network spanning 100,000 miles. The Meuse-Argonne offensive would prove whether American industrial logistics could sustain modern warfare's unprecedented consumption rates, or whether German confidence in American incompetence was justified. German General Erich Ludendorff's March 1918 intelligence assessment of American military capability reflected professional military analysis grounded in European experience and careful observation of American organizational methods. The Americans demonstrate considerable tactical enthusiasm, but lack systematic organization, Ludendorff noted in his strategic review. Their supply services show the characteristic inefficiency of unmilitary commercial practices. They will require years to develop the staff expertise and logistical discipline necessary for modern warfare. This assessment wasn't mere prejudice, but careful evaluation based on German observation of American forces. During their first months in France, German intelligence officers documented American supply confusion, reported instances of units receiving wrong equipment, and noted the apparent chaos as American forces attempted to establish their logistics system. The German evaluation reflected established European military doctrine regarding supply operations developed through 4 years of industrial warfare. German staff officers studied at Kriegsakademie, where supply logistics formed a specialized technical discipline requiring years of professional military education. The German general staff system separated combat operations from supply administration, with dedicated ETAP and inspection officers managing rear area supply through carefully calculated tonnage requirements, railroad capacity assessments, and systematic depot networks. French supply doctrine similarly emphasized professional military control, with the direction de l'arrière coordinating supply through established systems inherited from peacetime administration. British supply operations followed methodical procedures developed through 3 years of Western Front experience, with the Quartermaster General's department controlling distribution through fixed depots and scheduled deliveries. American supply methods appeared fundamentally different, and from European perspective, fundamentally wrong. The American services of supply operated under civilian railroad executives and industrial managers temporarily commissioned as military officers. William Wilgus, former vice president of the New York Central Railroad, held the rank of colonel while directing French railway construction. Samuel Felton, president of the Chicago Great Western Railway, became a brigadier general overseeing port operations. These men applied commercial railroad management techniques, competitive bidding for construction contracts, efficiency studies of loading operations, standardized scheduling systems, and performance-based personnel evaluation. To professional European military officers, this represented dangerous amateurism, the application of civilian business practices to military problems requiring systematic staff work and hierarchical control. The German military's confidence in its assessment rested on documented American logistical failures during the first American offensives. At Cantigny in May 1918, American units exhausted their ammunition supplies within 3 hours, requiring French artillery support to complete their limited objectives. During the Aisne-Marne operation in July 1918, American divisions received rations intended for French units, creating confusion about supply allocation. German intelligence reports documented these incidents as evidence of systematic American organizational deficiency. German planners calculated that American logistics could not sustain offensive operations exceeding divisional scale for longer than 48 hours without supply breakdown. This calculation informed German defensive planning for autumn 1918, when German commanders anticipated that American offensives would collapse from logistical exhaustion before achieving strategic results. The transformation of American military logistics from peacetime administration to industrial warfare capacity began not in France but in offices across the United States during spring 1917. The challenge wasn't military but industrial: how to project American economic capacity across 3,000 miles of ocean and transform it into combat capability in France. President Woodrow Wilson's administration faced this problem by appointing men whose expertise came from managing America's largest industrial enterprises rather than from military education. Secretary of War Newton Baker selected these individuals based on their demonstrated ability to coordinate complex industrial systems, railroad networks spanning continents, steel production facilities employing tens of thousands, and distribution systems moving millions of tons of freight annually. The key figure in developing American logistics doctrine was William Wilgus, whose career embodied the transformation of American industrial management. Wilgus had directed construction of New York's Grand Central Terminal, a project requiring coordination of 10,000 workers, excavation of 3 million cubic yards of earth, installation of 32 miles of underground track, and completion on schedule despite operating through Manhattan's densest urban environment. His methods emphasized systematic planning, detailed scheduling, efficient resource allocation, and accountability for results, precisely the techniques European military officers considered inappropriate for warfare. When commissioned as a colonel in the Army Corps of Engineers in June 1917, Wilgus brought these industrial management principles directly into American military logistics planning. Wilgus arrived in France in September 1917 with explicit instructions from General John Pershing: assess French railway capacity and develop plans for expanding infrastructure to support 2 million American troops by mid-1918. What Wilgus found contradicted everything European military doctrine suggested about supply operations. The French railway system operated at capacity serving French and British forces. French military railways used light tracks suitable for peacetime traffic, but inadequate for wartime tonnage requirements. The French chemin de fer network included numerous small regional lines rather than high-capacity trunk routes. Most critically, French military supply doctrine emphasized distributing supplies forward from Paris rather than landing supplies directly at forward ports and moving them inland through dedicated military railways. Wilgus recognized immediately that supporting American forces through existing French systems was impossible. His solution reflected American railroad industry practice: construct an entirely separate American-controlled railway network, dedicated exclusively to military traffic, built to American engineering standards, operated by American railroad personnel, and designed for maximum freight capacity rather than military protocol. This represented fundamental deviation from European military practice. French and British forces operated through existing civilian rail infrastructure, supplemented by light military railways in forward areas. Wilgus proposed constructing heavy-duty military railways comparable to American transcontinental main lines, capable of moving 30,000 tons daily per line, triple the capacity of existing French military railways. The organizational structure Wilgas created abandoned European military hierarchy in favor of American corporate management. Rather than operating through French railway administration or American military supply officers, Wilgas established the Transportation Corps as a semi-autonomous organization directed by former railroad executives and staffed by American railway workers enlisted directly into military service. These men understood railroad construction and operations through practical experience rather than military training. Track foremen from the Pennsylvania Railroad supervised construction gangs. Dispatchers from the Santa Fe Railway coordinated train movements. Maintenance engineers from the Great Northern Railway managed locomotive repairs. This civilian expertise, commissioned into military service, would construct the infrastructure supporting American offensive operations. The industrial capacity mobilized to construct American logistics infrastructure in France exceeded anything attempted in previous military operations. By November 1917, the services of supply employed 350,000 American soldiers and civilian workers in rear area construction, supply handling, and transportation operations, more personnel than the entire American Expeditionary Force's combat strength at that date. This ratio, 3 logistics personnel for every combat soldier, contradicted European military practice, where supply troops represented roughly 15% of total force strength. The scale reflected American recognition that industrial warfare required industrial-scale logistics organization. Railway construction demonstrated this industrial approach. American engineering units built 3,012 miles of standard-gauge railway track between January and December 1918, an average of 251 miles per month. This construction rate exceeded the monthly average for American transcontinental railroad construction during the 1880s. The Engineering Corps deployed 42 track-laying battalions, each comprising 1,200 men organized exactly like civilian railroad construction gangs, survey teams marking routes, grading crews preparing roadbeds, bridge construction specialists, track-laying teams, and ballasting units. These battalions used American construction equipment shipped from the United States, steam shovels manufactured by Marion Steam Shovel Company of Ohio, pile drivers from American Bridge Company, rail bending machines from Ralston Steel Car Company. American methods prioritized construction speed over military protocol, with track-laying crews working 12-hour shifts, 7 days weekly, using piece-rate pay systems to incentivize rapid completion. Port construction illustrated the scale of American logistics infrastructure. The services of supply identified 10 French ports for expansion into American military supply bases: Saint-Nazaire, Bordeaux, La Pallice, Brest, Le Havre, Nantes, Bassens, Pauillac, Verdun, and Rochefort. Each required massive construction to handle American supply volumes. At Saint-Nazaire, designated as the primary American port, construction included 21 miles of dock frontage, 75 miles of standard-gauge track within the port complex, 100 warehouses, totaling 1.5 million square feet of covered storage, 15 electric gantry cranes, capable of lifting 30 tons each, dedicated hospital facilities for 2,000 patients, and housing for 50,000 American port workers. This single port's capacity exceeded the total supply handling capability available to American forces during the Spanish-American War. Storage depot construction demonstrated systematic application of industrial warehousing practices. The services of supply constructed 7 major supply depots between January and August 1918. Is-sur-Tille for ordnance, Gevres for general supplies, Montier-Chaume for quartermaster stores, Tours for medical supplies, Mehun for aviation equipment, Jontry for chemical warfare materials, and Cosne for engineer supplies. Gievre, the largest depot, covered 18 square miles and included 1,250 buildings, providing 3.5 million square feet of covered storage, 180 miles of interior standard-gauge railway track, 50 miles of narrow-gauge track for internal movement, refrigeration facilities for 1 million pounds of perishable foods, bakery capacity for 500,000 pounds of bread daily, and dedicated power plants generating 5,000 kilowatts. The depot employed 25,000 American soldiers in supply handling operations, using mechanized equipment including electric forklifts, conveyor systems, and overhead cranes. Industrial material handling equipment previously unknown in military supply operations. The telephone and telegraph network constructed by the Signal Corps illustrated the communications infrastructure supporting American operations. Between March and November 1918, Signal Corps personnel installed 100,000 miles of telephone wire, constructed 273 telephone exchanges, and established 14,000 miles of telegraph circuits. This network connected every American headquarters from General Pershing's forward command post to supply depots 200 miles behind the front. The system used American commercial telephone equipment, switchboards manufactured by Western Electric, copper wire from American Steel and Wire Company, and telephone instruments from Kellogg, Switchboard, and Supply Company. Signal Corps operators, many recruited directly from American telephone companies, handled 150,000 calls daily during major offensives using commercial telephone company procedures rather than military signal protocols. The comparison between American logistics scale and pre-war military planning assumptions revealed the industrial transformation of warfare. The United States Army's 1915 mobilization planning documents estimated that expeditionary operations in Europe would require approximately 50,000 tons of supplies monthly to support 500,000 troops, a planning ratio of 100 pounds per soldier per month. Actual American supply operations in France during 1918 landed 7.5 million tons of supplies, supporting an average force strength of 1.5 million troops, a ratio of 5,000 pounds per soldier annually, or 417 pounds monthly. The pre-war planning estimate was off by a factor of 4. This miscalculation wasn't American incompetence, but systematic underestimation of industrial warfare's consumption requirements. Artillery ammunition alone consumed tonnage exceeding all pre-war supply estimates, with American forces firing 4.2 million artillery shells during the Meuse-Argonne offensive, more shells than the entire United States Army's stockpile in 1914. The first major test of American logistics infrastructure occurred during the Saint-Mihiel offensive, September 12 to 16, 1918. First United States Army, commanded by General John Pershing, concentrated 550,000 American troops, supported by 3,010 artillery pieces for the reduction of the Saint-Mihiel salient. The offensive's logistics requirements exceeded anything attempted by American forces. Daily consumption estimates included 50,000 artillery shells, 1 million rifle cartridges, 300 tons of food, 100,000 gallons of gasoline, and medical supplies for anticipated casualties of 30,000. Colonel Hagood's Services of Supply Organization had 4 weeks to position these supplies within striking distance of American assault divisions while maintaining secrecy about offensive preparations. The solution demonstrated American logistics doctrine's fundamental difference from European practice. Rather than stockpiling supplies in fixed depots behind the front and distributing them forward through scheduled deliveries, standard European practice, American logistics officers positioned supplies directly adjacent to frontline units using dedicated ammunition trains that moved supplies continuously during offensive operations. The 1st Division received its ammunition supplies from 3 ammunition trains positioned at Resicourt, each carrying 300 tons of artillery shells and small arms ammunition. These trains remained within 5 miles of divisional artillery positions throughout the offensive, with trucks shuttling ammunition directly from trains to gun positions. This eliminated the depot-to-distribution point to battery supply chain used by European forces, reducing delivery time from 48 hours to 6 hours. Transportation planning for Saint-Mihiel illustrated American railroad management techniques applied to military operations. The Transportation Corps scheduled 225 dedicated supply trains, moving supplies to American forces between September 1st to 12th. These trains operated on fixed schedules published 72 hours in advance, with designated routes, arrival times, and unloading locations specified exactly like civilian railroad timetables. Train commanders, former railroad conductors commissioned as military officers, had authority to maintain schedules independent of military protocol, including priority over troop movement trains, when supply deliveries were time-critical. This violated European military practice where troop movements took absolute priority over supply transportation, but reflected American recognition that industrial warfare consumed supplies at rates requiring continuous flow rather than periodic delivery. The Meuse-Argonne Offensive, September 26 to November 11, 1918, tested American logistics at scales exceeding St. Mihiel by factors of magnitude. First, United States Army concentrated 1.2 million troops, the largest American military force ever assembled, supported by 3,980 artillery pieces, 324 tanks, and 840 aircraft. The offensive would attack through the most difficult terrain on the Western Front. The Argonne Forest's 20-mile-wide maze of ravines and ridges, crossed by only 2 roads suitable for heavy traffic. German defenders had spent 4 years fortifying this sector with 3 defensive lines, incorporating concrete bunkers, barbed wire networks, and pre-registered artillery positions. American logistics officers calculated that sustaining offensive operations through this terrain would require delivering 750,000 tons of supplies monthly, more tonnage than landed at all American ports during the United States' first 6 months in the war. Colonel Hagood's supply plan for Meuse-Argonne reflected systematic application of industrial logistics methods to military operations. The services of supply constructed 3 standard-gauge railway lines running directly to the Meuse sector, each capable of moving 10,000 tons daily. These railways connected to 7 supply depots, positioned within 20 miles of the front. Ligny-en-Barrois for ammunition, Sommet for general supplies, Rarecourt for medical supplies, Érisée-la-Petite for quartermaster stores, Nixéville for engineer supplies, Ave for aviation fuel, and Clermont for replacement equipment. Each depot operated 24 hours daily, using 3 8-hour shifts, with supplies moving continuously from depots to frontline units using 800 trucks dedicated exclusively to the Meuse sector. This continuous flow system contrasted sharply with European scheduled delivery systems, but enabled American forces to maintain offensive pressure despite consuming supplies at unprecedented rates. The ammunition supply system demonstrated American logistics' industrial character. American artillery, during the Meuse-Argonne, fired 4.2 million shells in 47 days, an average of 89,362 shells daily, or 62 shells per minute continuously for 47 days. This consumption rate exceeded the total shell production of any European nation during the war's first 3 months. Supplying this required systematized handling procedures adapted from American factory assembly line practices. Ammunition arrived at forward railheads and boxcars carrying 30 tons each. Dedicated unloading teams, organized exactly like factory workers with specialized tasks, removed shells from boxcars at rates of 300 tons per hour. Trucks carried shells directly to battery positions, where artillery crews stacked shells in pits adjacent to guns, eliminating intermediate handling steps. This direct depot-to-gun supply chain reduced delivery time to 4 hours compared to European systems requiring 24 to 48 hours through multiple handling stages. Medical supply operations illustrated the system's sophistication. The medical department established 175 field hospitals with 250,000 bed capacity within the Meuse sector. These hospitals consumed supplies at industrial scales: 30 tons of bandages daily, 5 tons of surgical supplies daily, 10 tons of medicines daily, and 200 tons of hospital equipment replaced weekly. Medical supply trains operated on 12-hour schedules, delivering supplies directly to hospital railroad sidings, where medical personnel loaded supplies directly into hospital storage without intermediate warehousing. This direct delivery system enabled American field hospitals to handle casualty loads exceeding 25,000 wounded weekly during peak offensive operations, casualty rates that would have overwhelmed European medical systems operating through traditional depot-based supply. The Meuse-Argonne offensive's logistics performance validated American supply doctrine through measurable operational results. American forces sustained offensive operations for 47 consecutive days, while advancing 34 miles through the most heavily defended terrain on the Western Front. During this period, the services of supply delivered 1.5 million tons of supplies to First Army, an average of 31,915 tons daily. This daily tonnage exceeded the total supplies delivered to American forces during the entire Spanish-American War. The supply system never failed to deliver required materials, despite road conditions that deteriorated from heavy rain beginning October 4th, and despite German artillery bombardment of American supply routes. Artillery ammunition supply demonstrated the system's capacity to support unprecedented consumption rates. American artillery fired 4.2 million shells during the offensive, including 1.2 million shells during the final 3 weeks when First Army expanded operations to include Second Army's Meuse Heights offensive. This 3-week consumption, 400,000 shells weekly, exceeded the entire French Army's shell stockpile at the war's beginning. The ammunition supply system delivered shells continuously, despite consumption rates varying wildly based on tactical situations, from 40,000 shells daily during consolidation phases to 180,000 shells daily during major assault operations. This flexibility contrasted sharply with European ammunition distribution systems based on pre-calculated tonnage allocations that couldn't adjust to actual battlefield consumption. Medical evacuation illustrated logistics sophistication. The medical department evacuated 122,063 wounded soldiers from frontline aid stations to base hospitals during the offensive, an average of 2,597 casualties evacuated daily. Peak evacuation occurred October 7th to 9th when American forces attacked the Kriemhilde-Stellung defensive line, generating 9,000 casualties daily. The medical evacuation system included 850 motor ambulances, 75 ambulance trains with 14,000 bed capacity, and 47 evacuation hospitals positioned along railway lines. Wounded soldiers traveled from battlefield aid stations to base hospitals within 12 hours, faster evacuation than achieved by any European army during the war. This speed resulted directly from American logistics' continuous flow methods rather than European scheduled movement systems. The contrast between American logistics performance and German defensive expectations revealed the miscalculation in German assessments of American capability. German intelligence estimates projected that American offensive operations would culminate to reach logistical exhaustion point within 5 to 7 days of maximum effort. German defensive planning for Meuse-Argonne assumed American attacks would stall when American supply system collapsed under sustained operational strain. German commanders positioned reserves to counterattack when American logistics failed. Instead, American forces sustained maximum offensive pressure for 47 days. German Army Group Crown Prince's after-action assessment admitted surprise at American logistics endurance. The American Supply Organization demonstrated capacity exceeding our estimates by substantial margins. Their continuous offensive pressure derived from logistics capability we did not anticipate they possessed. Casualty statistics documented the offensive's intensity and American logistics' ability to support it. First Army suffered 122,063 casualties, 26,277 killed, 95,786 wounded. These casualties represented 10.2% of forces engaged, lower than British casualties at Somme, 19.2%, or French casualties at Verdun, 15.4%. The casualty rate difference resulted partly from improved tactics, but significantly from logistics, enabling American forces to maintain artillery superiority throughout the offensive. American artillery fired more shells supporting First Army's operations than German artillery defending against them, the first time during the war that attacking forces maintained sustained artillery superiority. This superiority derived directly from American logistics' capacity to deliver ammunition at consumption rates European supply systems couldn't match. The recognition arc, German military understanding evolving from confidence in American logistics, incompetence, to acknowledgement of American capability, appeared in German military assessments throughout autumn 1918. German intelligence report dated September 15, 1918, after St. Mihiel. American supply operations show improved organization, but remain vulnerable to sustained operational strain. German assessment, October 1, 1918, after 2 weeks of Meuse-Argonne, American logistics demonstrate unexpected endurance. Their supply system maintains adequate support despite difficult terrain and heavy consumption. German Army Group Crown Prince evaluation, November 12, 1918. American Supply Organization proved capable of sustained operations at intensity levels we assessed as beyond their capacity. Their logistics methods, though unconventional by European standards, achieved results exceeding our planning assumptions. The post-war recognition of American logistics achievement came from multiple sources, each acknowledging that American methods represented fundamental innovation rather than fortunate improvisation. General John Pershing's 1919 report to the Secretary of War stated explicitly, "The services of supply organization constituted an essential element of American military success. Their application of industrial efficiency methods to military logistics created supply capability, enabling American forces to sustain offensive operations at intensity levels unprecedented in American military history." British military observers offered particularly significant recognition given British skepticism about American organizational capability earlier in the war. Field Marshal Douglas Haig's November 1918 assessment noted, "The American Supply Organization achieved results through methods differing substantially from British practice. Their emphasis on continuous supply flow rather than scheduled distribution, and their use of civilian industrial management techniques, created logistics capacity we did not anticipate. These methods merit serious study for application in future operations." French military authorities, initially most skeptical of American capabilities, acknowledged the transformation most explicitly. Marshal Philippe Peytain's 1920 analysis stated, "The American services of supply demonstrated that modern warfare's logistics requirements exceed traditional military administration capacity. Their success resulted from applying industrial organizational methods, railroad management systems, factory production techniques, and commercial efficiency standards to military supply operations. This represents a fundamental innovation in military logistics doctrine." The German military's post-war recognition proved most significant because German pre-war assessments had been most confident about American organizational deficiencies. General Erich Ludendorff's 1919 memoir acknowledged, "We miscalculated American organizational capability. We assessed their commercial approach to military logistics as amateur incompetence. We failed to recognize that their industrial management methods created supply capacity exceeding European military administration systems. This miscalculation contributed to our strategic failure in autumn 1918. Statistical comparisons between American logistics and European systems documented the scale of American achievement. The American Expeditionary Forces landed 7.5 million tons of supplies in France during 18 months, more tonnage than British forces landed during the war's first 3 years. American forces constructed 3,012 miles of railway in 12 months, more track than existed in Belgium at the war's beginning. American port operations handled peak monthly traffic of 900,000 tons at Saint-Nazaire alone, exceeding the total monthly cargo handling capacity of New York Harbor in 1914. These comparisons revealed that American logistics represented not merely efficient administration, but industrial-scale organization unprecedented in military operations. The legacy of American logistics innovation influenced military doctrine development during the interwar period. The United States Army's 1920 Field Service Regulations incorporated services of supply organizational methods as standard doctrine, including continuous flow supply systems, civilian technical expertise in military logistics, and railroad management techniques for military transportation. The British Army's 1922 Supply and Transport Manual incorporated American continuous supply methods alongside traditional British scheduled distribution systems. German military theorists studying American logistics methods recognized them as exemplifying industrial warfare's organizational requirements, with General Hans von Seeckt noting in 1921, "Future warfare will require logistics organization following American industrial methods rather than traditional military administration. The nation that masters industrial logistics organization will possess decisive advantage in sustaining modern warfare's consumption rates." The specific innovations that made American logistics effective: continuous flow supply systems, direct depot to user delivery, civilian technical expertise in military operations, and railroad management applied to military transportation, became standard military logistics practice during World War II. The United States Army's logistics organization, in World War II, replicated services of supply structure and methods on vastly expanded scale. with the Army Service Forces directing logistics operations following the same organizational principles Hagood and Wilgus established in 1917 to 1918. American logistics performance during World War II, supporting 16 million personnel globally, delivering 450 million tons of supplies overseas, and maintaining offensive operations simultaneously on 3 continents, represented the direct application of organizational methods proven effective during 1918. The fundamental lesson of American logistics in World War I, that industrial warfare requires industrial logistics organization, shaped military thinking about modern warfare's industrial character. Traditional military logistics doctrine emphasized careful calculation, scheduled distribution, and professional military administration. American logistics demonstrated that industrial warfare's unprecedented consumption rates required different organizational methods: continuous supply flow, maximum throughput capacity, civilian technical expertise, and commercial efficiency standards. This recognition transformed military logistics from specialized military administration into application of industrial management principles to warfare's supply requirements. The broader significance of American logistics achievement in World War I lay in demonstrating that modern warfare required not merely military expertise, but industrial organizational capability. The German military's pre-war confidence that American forces would prove organizationally incompetent reflected traditional military culture's assumption that warfare required professional military training and hierarchical discipline. American logistics success proved that modern warfare increasingly required industrial management skills, technical expertise, and organizational methods developed in civilian industrial enterprises. This represented a fundamental shift in warfare's character, from professional military art to industrial enterprise, that would define 20th century military operations. The American services of supplies construction of 3,000 miles of railway, delivery of 7.5 million tons of supplies, and support of the largest American military offensive in history didn't merely enable American military success in 1918. It demonstrated that industrial warfare had fundamentally transformed military operations from traditional military art into industrial enterprise, requiring not merely professional military expertise, but systematic application of industrial organizational methods to warfare's unprecedented logistical demands.